Good morning, students. So today, classification of solids. So in the last chapter also we classified on the basis of resistivity and also on the basis of the energy band. So here we have the simple classification. So classification of solids, that is solids are classified into conductors and insulators. Right. So what are conductors? So conductors are substances which allow or which pass the electricity. The substances which pass the electricity easily or it allows the electricity easily, so that type of the substances we call as conductor. Substances or materials, right? So those are called the conductors. So examples for the conductor are all metals, right? So along with the human body and animal body, so along that so these are all the few examples for the conductors, right? So we already know the classification of solids, that is conductors and insulators, right? So next, the why the conductors easily allow the electricity. So the reason because the substances which contains charges, so which are easily moved inside the material, right? So if we consider this one as one conductor, so in this conductor we have atoms. So atoms consist of the weakly bonded electrons. So electrons are called as the charges, right? So those charges are easily moved inside the material, right? So for that purpose, the substances which easily flow the electricity, that means flow of electrons per unit time, we call as the current, right? So hence this material we call as conductors, right? So why we call that one as conductor means because they easily flow the charge carriers inside the materials, hence for that reason it easily flow the current, right? So those materials we call as conductors. So next, insulators, the material which does not allow the flow of current or electricity, right? The substances which does not flow the electricity, then those we call as insulators, right? So here few example for insulator, that is all non-metals, along with that glass, plastic. So these are the few examples for the insulators, right? So next, charges we are going to discuss in this the chapter is about the charges, right? So here we have two cases. One is conductor and another one is insulator, right? So when we put or we distribute some of the charges to the conductor, right? So when we given few charges to this conductor, either it may be positive charge or it may be negative charge, then the charges will reside all over the surface of the conductor. So within a short time, all the charges are distributed on the surface. So this one is in rectangle. So if it is the conductor is in spherical, so all the charges will reside on the surface of the conductor, right? So next, if we given the charges, that means if we electrified the insulator, that means we are giving the charges at this place, means the charges will reside in that place only, right? So this is the difference when we charges are giving into the conductor and when we given the charges to the insulator. When we given the charges to the insulator, at which place we are inserting the charges or giving the charges, so in that place only the charges will reside. So if we given the charges to here, that means the charges will reside here only. So it will not flow across the that is the material, right? So that is the difference in conductor and insulator, right? So next, if a conductor is connected to the earth, as earth is also the conductor, right? So then here the charges, that means the electrified object gets the neutral when the conductor is connected to the ground or earth. All the charges which are present on the charged body, it gets neutral. That means the charges which are present on this conductor becomes zero, right? So the process we call as, that one is earthing, or we call that one as grounding, right? So when a charged body is connected to the earth, right? So by through a conductor, right, the charges which are present on this conductor will flow across this conductor and it went to the earth, right? So that process we call as earthing or grounding, right? So this is about the conductors and insulators. Next, so the next topic is the methods of charging. Right, so here we have three methods of charging. So first one is charging by friction. So the first one is charging by friction. So next, the second one is charging by conduction. So next, third one is charging by induction, right? So these are the three methods of charging a neutral body. That means we are adding or removing so electrons from that body, then that body gets charged, right? So that body becomes electrified. So if we start with the first one, that is charging by friction, right? So friction is nothing but when we rub any two bodies, then two bodies will gain the charges. So one body will gain one kind of charge and the another body will gain the another kind of charge. So that process is called as charging by friction. That means when we rub any two bodies, then one kind body will gain the one kind of charge and the another body will gain the another kind of charge. So that process we call as charging by friction. So as already we discussed in the last class, that is when glass rod is rubbed with silk cloth, right? So glass rod attains, that means it gains one kind of charge, that means it loses its electron. So hence glass rod becomes positive charge and the silk cloth will gain the negative charge. So here the gaining of the one kind of charges on one object and the another kind of charges on the another object. So here the same number, the quantity of charges which acquired on the body is in the same, that means in the equal amount, right? The charges gained by the objects are in equal amount, right? So if the glass rod gains 10 positive charges, so same quantity of the silk cloth will gain, that means minus 10 charges, that means in the equal in number, right? So charging by friction is best method to electrify the insulator. So that means the friction takes place in insulators, right? So here opposite charges are gained. So if we are rubbing with the two bodies, then one body will gain one kind of charge and another body will gain another kind of charge. That is, if one gets positive, the another will be negative. So there is no gaining of two materials with the same charges, right? So if we rub the glass rod with the silk, so glass rod is positive, in the same way the silk will not be positive. So opposite charges will be obtained when we charged by the method of friction, right? So this is the about friction. So important is it takes place only in the insulator. The best way to charge the insulators means that is by the method of friction, right? So here opposite charges will be gained on both the objects, right? So next, charging by conduction. So it is a process in which when an uncharged body is kept in touch with the charged body, right? So here we have one uncharged body, right? So this uncharged body is made in touch with the or made in contact with the charged body, right? So then the charges will distributed all over the surface of the uncharged body, right? So this process we call as charging by conduction, right? So charging a uncharged body or neutral body by making made in touch with the charged body, right? So here keep in contact. So two different objects are made in contact with one another. That is, uncharged body is charged when the charged body is in touch with the neutral body. So if we call this one as neutral body or neutral object. So this one is the charged object. So this conduction is better in, that is, it takes place in conductors, right? So next, the charges which attained by the neutral body, that is distribution of the charges, either may or may not same. So charges which acquired by the neutral body is same as that of the charged body, or it may be less than that of the charged body, right? So if this charged body has 10 positive charge, then neutral body can gain only 5 positive charges, right? So that means, or it can gain 10 charges, either it may be equal or it may be less than that of the charged body, right? So when these two will be equal, when the two objects are same, right? So if two objects are same, then the charge distribution will be same. If two objects are different, then charge distribution will be vary, right? So here similar kind of charges are acquired by the neutral body, right? So if the charged body is positive, then the neutral body will gain the positive charges only, right? But in insulators, that is in friction, opposite charges, right? So two body will gain the two different kinds of charges, but in case of by the method of conduction, the similar charges will be gained by the neutral body. If the charged body is positive, then the neutral body will also gain the positive charges. If the charged body is negative, the neutral body will gain the negative charges. That means similar kind of the charges will be on the neutral body, right? So the charges may or may not be same. So when it is same, means the two bodies are similar. So if two bodies are similar, then the charges will be same. If two bodies are different, then charges will be not same, right? So this is about the charging by conduction. So conduction takes place in conductors. So similar kind of the charges will be obtained on the neutral body. Next, the charges which obtained by the neutral body may be or may not be same, right? So when it is same means both the bodies will be same, then only the charges distribution will be same. So when the bodies are two different bodies means the charges will be less than that of the charged body, right? So next one is charging by induction. So it is slightly different from the charging by conduction. So in charging by conduction, the charged body has to made in contact with the neutral body, but here the charged body is placed some distance from the uncharged body, right? So this one is the neutral body. So if the glass rod is positively charge, right? So this neutral body also consists of the initial number of the charges. That means plus, minus, plus, right? Like this, it consists the few charges, right? So as already we know, the like charges will repel each other and unlike charges are attract each other. So from that reason, so here this charged body is positively charged. Next here, so due to the polarization, that is from the opposite charges are attracting. So here we have positive charges, then the negative charges will be towards that of the positive charges, and the positive charges will be away from the charged body, right? Now if we connect this one to the ground, that is earthing, so this positive charges are flows into the ground, so remains only the negative charges, so those charges are equally distributed over the surface, right? So hence here this body gets electrified, right? So charging by induction is also takes place in conductors. So here, if the charged body is positive, then the neutral body will get the opposite charges, that is opposite charges are gained by the neutral body, right? So this method is the charging by induction, right? So charging a neutral body by placing nearer a uncharged, that is charged body, then it gains the opposite type of charges, right? So that process is called the charging by induction, right? So these are the key points. So next, properties of charges. Right. So the first properties, as already we discussed, that is like charges repel and unlike charges attract each other. So this one is the first property. So this is very important for 3 marks. Right. So we have nearly 5 to 6 properties are there. So in the last year, in 2019, they asked this for 3 marks, right? So if they ask for 3 marks, just we need to write the statement. That means 3 statements. So this one is the first statement. Like charges repels, unlike charges attract each other. So next, second one is charges are charge is conserved. That is conservation of charge. That means the charge is neither be created nor be destroyed, but it transfers from one form to the another form. Or in the another way, we can say in an isolated system, the charge is conserved. So in an isolated system, the charge is conserved. So that means, as we already discussed in nucleus, right? So nucleus consists of protons and neutrons, right? So this neutron is, the charge of the neutron is 0. So the charge is denoted by Q, that is equals to 0, right? So this neutron is gets decayed into or it converted into proton and electron, right? So this neutron is converted into proton and electron. So proton is positively charged and electron is the negatively charged. So these two have the same values, right? So that means here we have positive value and here we have the negative value, right? So before conversion, the charge of the neutron is 0. Then after conversion, that is after decay of the neutron into proton and electron, so the sum of the charges, right? In an isolated system means the sum of the charges is conserved is nothing but the sum of the charges again equals to 0, right? So that gives the charge is conserved or conservation of charge. That is, the charge is neither be created nor be destroyed, but it converts from one form to another form, right? So this one is the example for the conservation of charge, right? So the next, charge is invariant. That means when charge at rest is equals to charge in motion. That means the value of the charge will not alter when the charge is in rest and when charge is in motion. So the value of the charge remains same. So hence we call the charge is invariant, right? So this one is the third property. So next one is charged body attracts light uncharged body due to polarization of uncharged body, right? So this one is the fourth characteristic. That means charged body attracts the light uncharged body. That is because of the polarization, right? So if we consider one charged balloon, for example, here we are taking one balloon. So this balloon is charged. That means it has, either we can take this one as positive charge or negative charge, right? So this balloon is placed on the wall, right? So this wall is neutrally charged. So due to polarization, here it is positively charged. So due to polarization, the charges which are present in this wall is separate. That means the negative charges will be on the one phase and positive charge will be on the another phase, right? So from this, here we have positive charge, here we have negative charge, right? So that means opposite charges attract each other. Hence, the balloon will stick to the wall, right? So the balloon is stick to the wall. That is because of the polarization of the uncharged body. So here the uncharged body is the wall. So balloon is the charged body, right? So due to polarization, the balloon will stick onto the wall, right? So this one is the fourth characteristic. And the next one is charge is additive. So charge is additive, nothing but, so in an isolated system, so if we consider here one system is there, right? So here we have many number of charges, Q1, Q2, Q3, Q4, like this, right? So these charges in this system is added like a normal mathematics, so normal addition, right? So the system consists of here 4 number of charges, so it simply adds up, right? So that is the additive of charge, that is the net system charge, that is in the system we have the net charge Q, that is equals to Q1 plus Q2 plus Q3 plus Q4, because charge is scalar. So it adds up like the masses, right? So for example, if we consider one bag, right? So this is one bag. So this bag consists of some 5 kg of rice and some 5 kg of, that is 4 kg of sugar, right? Then some 3 kg of salt, right? Then the total mass in this bag is how much? So we can easily add, that is 5 plus 3. So 5 plus 4 plus 3, right? That means 12 kg. In the similar way also, if we consider this one as one system, or if we consider this one as one conductor or insulator, it has the charges Q1, Q2, Q3, Q4. Then the net charge in this system is simply we adding the charges, right? So Q1, Q2, Q3, Q4. So if it has n number of charges, right? So up to n number we have the charges, then the net charges will be plus Qn, right? So the only difference between the addition of masses to the addition of the charges is that the mass is only positive. So if we consider this one is mass, so this mass is only positive, right? So if we add the masses, then only we get the positive values. But here in charge, it may be positive, it may be negative, or it may be zero, right? So if we consider here one system, so here we have plus 1, here we have minus 2, and here we have plus 4, right? Then net charge in the system Q net, that is equals to 1 minus 2 plus 4, right? So 1 plus 4 5 minus 2, that is 3. So similarly, if we take 1 minus 2 minus 4, Q net is equals to 1 minus 2 minus 4, that is minus 6, then plus 1, it becomes minus 5. So here the net charge in the system is negative, then we call this system is negatively charged. So here the system is positively charged. The next is here, if we take 2, here 2, right? So Q net is equals to 2 plus 2 minus 4. So it becomes 0. The net charge. So, but it is very important, they ask for several times, right? So the next sixth property is charges are quantized, right? So all free charges are integral multiple of basic unit of charge. So all free charges are the basic unit of charge. So this one is saying the quantization. So if we consider any charge, right? So if this one is the charge Q, so this charge Q is the integral or summation. We call both, right? So summation, that means sum of all the basic unit of charges, right? So then we can write this one Q is equals to N into E, right? So here the basic unit of charge is E. So this E is either proton or electron, right? So when N is integer, right? So when N is either positive or negative. So if N is positive, then it is proton. So N is negative, then it is electron, right? So the value of the basic unit of charge E, that is equals to 1.6 into 10 to the power of minus 19 Coulomb, right? So for proton, we are taking positive value. For electron, this one is for proton. For electron, E is equals to minus 1.6 into 10 to the power of minus 19 coulomb. Right? So this gives the quantization of charges. Right? So any system having the charge, that is Q is equals to 1 coulomb. Right? 1 coulomb charge, that means calling the charge having 1 coulomb, that means how many times it consists of the basic unit of charge, that is E. That means we need to find N, right? So here they given 1 coulomb, that is equals to N into, so E value is 1.6 into 10 to the power of minus 19. Then N is equals to 1 divided by 1.6 into 10 to the power of minus 19. So if it goes to the numerator, it becomes 10 to the power of 19 divided by 1.6, right? So or this can be written as 10 divided by 16 into 10 to the power of 18, right? So here 2 5s are 10, 2 8s are 16, right? So 0.86 are 48, then again 20, 6.2 into 10 to the power of 0.62 into 10 to the power of 18, keeping as is 19. Because we are shifting one decimal means here 10 divided by 60. So this value N is approximately 6 into 10 to the power of 9 plus 18 electrons, right? So 1 coulomb of charge contains how many electrons? That is 6 into 10 to the power of 18 electrons or positrons, that is protons, right? So this coulomb, that means this value is larger value, hence the coulomb we call this unit. So this is very large unit, right? So balance to this one, always we taken coulomb with the prefix either by microcoulomb or by the millicoulomb, right? To define the charge unit, so this value is very large, that is coulomb value is having 6 into 10 to the power of 18, right? So this one is a positive value, so the coulomb unit is very larger value, right? So but in the macroscopic level we are discussing about the charges, that means it is very small, right? So for that purpose, to balance that one, we are using to measure the charge, that is either in microcoulomb or in millicoulomb, right? So these are the properties of charges, right? So the first property is like charges repel each other and unlike charges attract each other. The second property is the charges, we can say this one, charges are quantized and charges are next additive. For 3 marks, if we write this much only, we can get the marks along with this relation, that is Q is equals to N into E, and we need to mention what is N. So N is integer, and when E is either proton or electron, and the basic unit of charge is E, right? That is 1.6 into 10 power minus 19 coulomb. That is charge is invariant, right? So the main are the charge is additive, charges are quantized, charges are conserved. Then the charged body attract the light, uncharged body, that is due to the polarization, right? So these are the properties of charges, and these are very important. Several times they ask for 3 marks. Next, so if you move on to the next one, that is the main important topic starts from here. So this will be carried for nearly 3 to 4 chapters. So even also we discussed this topic in atoms, nuclei, right? So that one is the Coulombs Law. So very important. This year in 2020 they asked the statement for 2 marks. This year also they asked this statement. So this law is similar to that of the gravitational law. So in the class 11 you already studied the gravitational law. So same law here we apply in charges, right? So considering 2 point charges, right? Either of same charge or of different charge. That means point charges. So considering here Q1 and Q2 are the 2 point charges. So as these two are similar charges, then there is a force of repulsion, right? So this one is the force of repulsion between two charges, right? So if we consider two opposite charges, that is plus Q1 and minus Q2. So here we are taken two cases. So one is two similar charges, that is positive charges. In the second case, one is positive charge and another one is negative charge. So here there is a force of attraction between these two charges, right? So now these two charges are separated by a distance, that is finite distance or small distance, that one is r. So here also same r, right? So only these two possible cases, that means two charges separated by a finite distance, right? So one is considering the cases both are positive or both are negative. So if both are positive also we get repulsive force, if both are negative also we get the repulsive force, right? So the next is one is positive charge and another one is negative charge. So here there is a attractive force. So here this force is the repulsive force and here the force is attractive force, because from the properties of charges, that is like charges repulse and unlike charges attract. So now if we define, that is in Coulombs law we are going to define, that is force. So which force it is? That is force of repulsion or force of attraction, right? The force of attraction or repulsion between any two charges which are separated by a small distance, then that force is proportional to magnitude of the product of the charges and inversely proportional to the square of the distance between these two charges, right? So that is the statement of the Coulombs law, right? So if we return the statement, the force of attraction or repulsion between 2 point charges, the force of attraction or repulsion between 2 point charges separated by a finite distance, then force is directly proportional to product of magnitude of charges and inversely proportional to the distance between them or distance between the charges along the line joining between them. So This lengthy statement, each and every word is very important, and each and every word has meaning, right? So in between, if we neglect point charges, then magnitude, and then the last one along the line joining between them, right? Then the statement will go on wrong and they won't give any marks, right? So first, that is, as already said, the force of attraction or the force of repulsion between these 2 point charges separated by a finite distance. So here we take a distance as d, or we can take distance as r, right? So separated by the small distance or finite distance, right? So here this force is proportional to, right? So here this word is important, proportional. So which proportional? It is directly proportional, right? So directly proportional to the product, right? So product is multiplying product of magnitude of charges. So here we have the charge here is plus q1 and here we have minus q2. So only the magnitude means we are neglecting the sign here. Only taken the value q1 and q2, right? So that's given by the magnitude, right? So magnitude of charges and inversely proportional. So that force is inversely proportional to the distance between the 2 charges, right? That force, so as already we know, force is a vector quantity. So this vector has the direction that is along the line joining between the 2 charges, right? So force has direction, that means force is not somewhere like this here or somewhere like this here, right? So the force is always in the direction of the 2 line joining between the 2 charges, right? So there is a straight line between q1 and q2. So the charges will be either in direction or in this direction, right? So there is no force in any other different direction. So that means this line is also very important because the force is a vector quantity. That means this force has magnitude and also the direction, right? So this is the statement. Next, we need to convert this statement into the mathematical form, right? From the first statement here, from the first half, that is force of attraction or repulsion is directly proportional to the product of magnitude of charges. That means product means q1 into q2. Only we are taking the magnitude. That's why we are neglecting the sign of the 2 charges. That is q1 and q2. The next is the force, the same force is inversely proportional to the square of the distance between the 2 charges, right? So now we need to combine these 2 statements, right? So if we combine those two, then F is proportional to Q1, Q2 divided by R square, right? So now we need to remove the proportionality constant, then F is equals to K into Q1, Q2 divided by R square. So this is the statement of the Coulombs law in mathematical form, right? So this will be continued in our next class, right? Thank you.